Okay, so welcome to this session. Actually, I'm just checking the participant. I think we have reached maximum, which can be handled in a Zoom meeting. Okay, so it's like 100 already. And so anyway, this session is being recorded. Those who have come on time, you have been chanceux. Okay, so that's good. Anyway, if need be, we can organize another one later on, or if we are recording this session anyway. So those are going to benefit from it. But you are going live, so you are watching it live, and you can participate in it live. So thank you for being on time, and happy Independence Day, just to start with. And just checking. Yes, is the audio in? Can you hear me?
Yes, sir.
Okay, that's good. Very good. So thank you for being on time. I was saying, so I'm monitoring the chat and the participant. I think we are full. No one, I think, will have access more because we are 100. Anyway, so let's get started. It's like a 1.5 hour session. I'm planning it in this way. And so you can intervene in terms of the chat. We have some ground rules which we are going to see. And let's make good use of this confinement and see how we can improve, how we can grow out of this session. I'm going to enter the presentation mode now. Okay, so there we go. So my aim is to give you my perception about the training, how the training should be like, could be like, and what we expect from the receiving end, from an assessor perspective or from a supervisor even, how we expect you to do your training, how do we expect it to go through. And if you are having some questions, we'll see how we are going to manage questions just after a few slides. The report writing, we are going to discuss about the report writing, because the training basically, as soon as you get into a training environment, you are enrolled at a specific place, and you have the opportunity of undergoing training. Okay, and but how do you write the report? What do you need to do? Maybe so some questions which you have, and which I will try to answer from our own perspective. And then we are also blessed to have Mr. Dalia, the chairman of CRP, who is with us. So he's going to intervene at a later stage. And if he wants, I don't know where I'm going to look for him in the list of 100 participants. I'm still receiving some messages that people are not able to connect. And anyway, we'll see how we organize something else for these people. So we have an interest, as you have seen. It's something which is interesting for you and young engineers. And then, so a last part will be about the interview. At times it is daunting, okay, because I'm working with trainee engineers myself at the CB. I'm going to introduce myself. So this is a step where they are afraid. They don't know what's coming. Is it like going to be like an exam? So how is it going to be? We are going to discuss about that as well. Okay, so people are still trying to get in. Okay, so who am I? Those who don't know me, I'm Ismail Essackjee. You can call me Ismail. Okay, so I'm a senior engineer at the Central Electricity Board. I work in the transmission department section, okay, where we construct new transmission line, and we project manage, we commission the line, we test, and so on. So we are at 66 kV and 132 kV, the design and implementation part. Okay, you will see there are so many post acronyms under my name. We are going to come to that later on. Why do we need to have these acronyms? Oh, do we need it? Okay, or is it just for the show? Okay, one which is important is RPM. This is why you are all here. Okay, to be registered. I hopefully think you are here to be registered. Okay, and you are here to understand the steps, maybe one or two things which are missing in your equation. You want to get the answer, and you can move forward on that. So I'm reachable on my email and on my mobile number, and you can have access to my website as well, coachsmile.info. Okay, so some ground rules, and just to start with, don't forget to wear your mask even attending this session. Actually, I'm just kidding. Okay, it's just that just to take the necessary precaution. If ever you are going out, the virus is out, and we don't want to mess with it. Okay, so take all your precautions. Every participant will be on mute. Okay, I'm muted everyone, I think, and only if you want to intervene, but I will see, let's keep it a flow. Okay, if you want to intervene, here you are, you can ask questions in the chat box. I most likely we are going to have lots of questions. I'm just checking the chat box. Okay, no. I may not be able to answer all your questions in the chat box, but it's going, as soon as I finish this presentation, I'm going to have the log of the chat book. So I may then maybe find some, if there are some, most of the questions, usually what happens that most of the questions that you have are going to be answered in the presentation itself. Okay, and in the end, Mr. Dahlia is going to intervene. I'm going to have a quick check. I'm going to run through the series of comments that we are having in the chat box. So try to minimize the comment, okay, and just ask questions if need be, so that I can run through it maybe quickly, okay, afterwards. And then I can, if there are some issues which I can answer, Mr. Dahlia can answer, or we have Yasin as well. I don't know if he's here, else he won't be able to join us because we're already full. Yasin, also another experienced engineer, wanted to join in at a later stage. If you had questions, he would have been pleased to answer, to participate. Okay, so this is how you can ask questions. And then the session is being recorded and the recording will be available. I will upload it on YouTube. Okay, and the link is going to be public. And I'm going to share it maybe on Engineering Opportunities, my Facebook page, or even my link. You will be aware about it. Okay, so let's get started. So most of you, okay, are here for some maybe specific questions that you have in mind. Okay, let's see. So who wants to register as a professional engineer? Most of you. Why? Okay, so these if we were in like in a classroom mode, we would have maybe hear a few answers from you, but just also say, why do you really want to be a professional engineer? Aren't you happy where you are, as you are? Okay, is it due to maybe at times in the past when I joined the service, okay, as soon as you register, it's easier to get married. You're going to have duty-free car and so on. Is it a reason, or is it something above that? Okay, just checking the chat. I'm seeing it is flashing. Anyway, let's continue. Is it going to be like an examination, this stage 2? Okay, so do I need to revise what I've learned from day 1 at the university to the last day? Okay, how is it going to be? How do engineers communicate better? I was like a super timid maybe student. Okay, I'm still super timid, but I've had to go to another level. Okay, to be able to communicate much better. So communication is not only in one direction. It is verbal communication, what we call oral communication. It can be written communication, different modes of communication. We are going to handle that. We are going to see how we can improve our technical writing, because we need to submit this report and we need to write proper technical English in that. So we are going to discuss about what is a project. Okay, if you are in a project environment or if you're in operations, how are these going to be different? Okay, so if you now understand what is a project, you can say, okay, what is project management? How do you manage a project better? What is a design exercise? Okay, very important part, because this is what actually demarcates an engineer from maybe a technician. Okay, we all need to have technicians, we need engineers, and we need different personnel even from management perspective. But then what differentiates an engineer from a technician? Okay, so it's two different maybe duties, but one item which comes to the mind is about the design. So the engineer is able, okay, is recognized to be able to do design and to be able to improve things. Okay, with experience, technicians as well, they gather experience, but they are going to work in a specific environment. Like an engineer, they can shift different environment. They have much a broader, what we call holistic approach to the design exercise. At times you are in maintenance. So what is maintenance? How do you do maintenance? Is it like routine maintenance? Even in maintenance, you have so many of design approaches, so many of facets of what we are going to call that competency, statement of competency that you need or you can gather if you're working in a maintenance environment. Okay, so is it when you started your training, they were doing it in specific way, maintenance. And after 2 years, is it still the same, or have you been able to improve one step? Have you been able to develop, let's say, simply a checklist, okay, or introduce a new approach, a new software to track maintenance and so on? So these are new things which engineers can think about and implement. What is the role of an engineer? So we have so many roles. Is it only to do design, to check, to do supervision, or is it above that? Okay, so many questions. I won't run through that. Solving engineering problems. Actually, we are here to solve problems. Okay, engineers are employed. Okay, they join an organization to solve engineering problems, and we are not here to create problems. Okay, that's why we need to groom ourselves to be able to help the society in these different aspects. Okay, so I'm having so many messages currently in. Okay, anyway. So designing within environmental constraint. Okay, I'm going to touch on that later on. We have it on one of the slides. Components of construction contract, leadership skills. Engineers should be leaders. Okay, most of the time you will see that you have lawyers, okay, going on the forefront, architect going on the forefront. But where are the engineers? Okay, engineers actually they work in the background. They do all the calculation, all the work in their office, on the site of work and so on. They are doing the job, but then when things are going to be commissioned and so on, we don't see them. Okay, so we need to develop we need to groom ourselves. We need to develop our communication so that we can talk, we can speak, we can be leaders in the new era that is ahead of us. Okay, so elements of an effective meeting. Are you attending meetings? Okay, these, it's like we are not going, you will see that it's not only going to be about technical things that we are going to discuss, because if you were trying to enroll on a BEng course, we would be discussing about what we are going to learn, signal processing, concrete, and so on. But here we are going to discuss about design. Yes. So what is design? It's an application of what you have learned at your university into real world problems. And then this is a core, but then all around this core, surrounding this core element, you're going to have attributes, okay, what we are going to call competencies that you need to develop during these 24 months of training. So some of which are leadership skills, communication skills, report writing skills, and running a meeting. Because we spend, okay, a lot of time in meetings. So how to make a meeting effective? Okay, what is a BOQ? So different questions which I've just noted down, but you may be having much more. Okay, so let's get started. Let's see the agenda for today. So we are going to see why do we need to register? Do we need to register, or is it like, okay, let's just try our luck? Okay, the legal provision and the role. We are going to see the training requirements. What is a training about? What do we need as to undergo this training? The technical report. Okay, the big chunk of today's discussion is going to be on the technical report. Statement of competencies. Okay, you say the technical report is going to reflect our core competencies, and then we have different additional skills which we need to develop as well during this training session. So the art and craft of technical writing. So we have the technical report, which we're going to discuss about what do we need to put in the report, and then how to write the report. This is the art and craft of technical writing. And then we are going to discuss about the stage 2, where you need to submit the report, you need to prepare yourself for the interview. How is it going to be like? So we are going to discuss all that. So why go for professional registration? It actually is going to show the commitment of the professional engineer to practice engineering within a legal framework. In a classroom environment, I usually ask this question at the beginning. So how many electrical engineers do we have in this as participants? Maybe a few are going to raise their hand. How many chemical engineers? Another batch are going to raise their hand. How many? I'm seeing a few hands going up. That's good, Ashfaq. You're going to hear from me shortly. How many civil engineers do we have? People are going to raise their hand. Then I'm going to rephrase the same question from a legal perspective now. how many electrical engineers do we have in this audience? You will see that all those who raise their hand, they are going okay, we do have a few, okay. And so most of the participants, they are not, so to be able to answer this question from a legal perspective, you need to be registered with a council. So a legal framework has already been laid, okay. This council, the CRP council is here to ascertain, to register engineers as per a certain set of criteria, which we are going to see. And you can't call yourself an engineer, okay, if you're not registered with a council. It's a law. C'est pas moi qui peux dire, it's the law, and we are law-abiding citizens. Okay. All our trainee engineers. Oh, I'm just okay. Yeah, but trainee engineers as well. In the past, they used to call it engineering trainees or things like that. Okay, not engineers, because it's a bit, the use of the word engineer is reserved for those who are registered. Okay, so it's going to reflect your degree of competence. In the same way, let's say, let's take it as another example. You have someone, your neighbor has gone to study medicine, okay, and he has come from abroad. And then you have another, maybe someone maybe living in your region. He has done his medical studies. He is registered with engineering council, and you are not feeling well. Okay, you are not. It's not only like a mild fever. You are maybe having difficulty to breathe and so on. Who are you going to go to seek advice? Is it going to be your neighbor or someone living close to you, or you will prefer to go for the one who is registered with a medical council and who is practicing? Okay, so you see the difference again. It's not that you don't have the competencies. The university, as soon as you complete your study, they're giving you a certificate. You have been assessed based on the different modules you have done, which are accredited or not accredited, but it is as per their program. Okay, this is okay. It's not about checking your competence in terms of technical competence, but here we are moving one step ahead, one step above, which is about professional competence. Okay, so that's why one of the reasons we need to meet the objective, the criteria set by the engineering council, and we register as professional engineers. Let's continue. Usually required for engineering, project management, procurement, or contract management. So being registered is, let's say, a first step to different career paths that you can have. If you're going to go into engineering project management, which is like a specific créneau, okay, or procurement, okay. So most of the time they will require that you are registered. If you're working in government or parastatal bodies, it is mandatory. Okay, it is always mandatory as such, but the way it is currently, the way we are looking at it, it is only those working in government is a requirement for you to be employed, else you won't be employed as a professional engineer. Okay, so it is an appeal to those in the private sector, okay, to register, because the law is here and we are going to see. Okay, so basically bottom line, what does it mean is a license to practice engineering independently. This is what we are giving you. It's just that you have got your car and now you have got your license. Okay, there's no one who is going to sit near to you, who is going to tell you, okay, now it's time to start braking, put your handbrake on or off. Okay, turn on the signals, the turn signals. No, there's no one who is going to be there. So this was your supervisor who was staying with you over these 2 years training, minimum 2 years of training. Now you are a fully fledged driver, engineer, professional engineer, and you can practice engineer independently. Okay, this is what it is all about. Now let's see, what if we do not do that? What does the law say? So we have the Registered Professional Engineers Council Act of 1966. Maybe a few of you were already born at that point in time. Registered professional engineer means a person registered as a professional engineer under this act. So this act that we are referring to defines what is a registered professional engineer. Okay, and we need to go according to this definition. Only upon registration that you can call yourself a registered professional engineer, and then you can use the abbreviation. Remember the list of abbreviations that I put at the beginning, RPM, okay, Registered Professional Engineer Mauritius. I wish you that you get this as soon as possible. Okay, now if you don't abide, if you're not a law-abiding citizens, Any person who, not being a registered professional engineer, takes or uses as a name or title registered professional engineer. Oh, so if you're not registered, you call yourself a registered professional engineer, or any abbreviations, either alone or in connection with any other title. So even though you don't need to put it as registered professional engineer, if you call yourself a registered engineer as well, it is prohibited by this law. If you call yourself a professional engineer, again, if you're not registered, it's going to be against this law. Or even if you call yourself engineer and you're not registered, it's going to be against this law. Okay, I'm just here to explain what is written there, up to you to make your own conclusions. Okay, advertise or holds himself out or subject to section 20, conducts himself in any way or by. Okay, so it's not only about calling yourself. If you are behaving as a registered, you're like behaving as a registered professional engineer. So it's not only about how you call yourself, but you advertise yourself, okay, or engages in the practice of engineering. What is meant by engaging? It is, okay. So what is engaging is about even giving advice, okay, do this way and so on. You're advising a party, okay, in engineering. So you're not registered, it is against the law. So what will happen to you? Maître Bracelet shall commit an offense and shall on conviction be liable for a first offense to a fine not exceeding 200 rupees. Évidemment, avec 200 roupies and McDonald's. So what is it about? And for subsequent, il y a une répéter, mais par 500 puis en l'amende, le chemin speed limit pour qu'on arrive 2500. So what about this one? And to imprisonment of a term not exceeding 3 months. Okay, just capable, you can have a fine, monetary fine, and then, pas mettre all, mettez and imprisonment for a term not exceeding 3 months. Car fait un petit moment. Mais 3 mois, okay. But what's going to happen now to your career? Okay, see the correct perspective of looking at this prohibited practice. You have already been sentenced that, so you have committed an offense, maybe someone has lost his life, and there are other maybe legal provisions for that, but maybe you have advertised yourself, you are doing something wrong, okay, and you have got a consequence, okay, maybe death, accident, injured person, and so on. First, you're going to be, as per this law, people pay, etc. But then there are other consequences as well. Maybe how is it going to be? How is the council going to look at your case? Okay, how is it going to be like your career as an engineer? Okay, so it may stop right there. So don't venture into going all through all these prohibited practice. So try to make good use of your training and complete your report. So that's why we are here, to help you proceed. So now the role of the professional engineer: promote health and safety. Okay, definitely. First things about health and safety. It's not about doing a low-cost design. Okay, first things about health and safety. Okay, second one is about protection of the environment. We need to take care. So we need to factor in the environment in our design nowadays. It's not about cutting down trees, building so many concrete structures and so on. We need to integrate, we need to think about sustainability in our design as well. Areas of competence. So as an engineer, okay, I'm an electrical and electronic engineer. Can I say I'm a professional engineer, I'm registered with the COP, but can I give advice on constructing a building? Like it's what we call a civil engineering practice. I can't, because I need to operate within my own competence. So this is a competence, a field of competence. Now, let's say I'm an electrical and electronic engineer. Okay, let's say an electrical engineer, but I've not been working in aviation. Okay, I have been specializing myself in power system, but I'm a registered engineer. So if I don't know anything about aviation, maybe what is the electrical engineering in aviation, can I start advising people there? Okay, this is a specific field in itself. It is electrical engineering, but this is outside my area of competence. So I need to know what I know and what I don't know. Okay, this is for areas of competence. Then it's practice of engineering. We have already discussed about what is meant by practice of engineering, giving advice and so on. Now, how about the training period? How much time do we have for the training? Okay, so it is said to be 24, not 24 heures chrono, but 24 months. So it is a minimum time period that you have to complete the report, the training and so on. Not the report, but the training as such. And this is a minimum. What is minimum? So that you can, if you're not ready, you can extend it to, depending on where you're working, the facilities that you have there, to go beyond 25 months, 26 months, 27 months, and so on. 2 years, 3 years, and then, but you need to put a time limit. So you need to plan for what you want to achieve. Okay. You can't, basically you need to put a timeline. Okay. Time bar to, okay, 24 months, I'm going to complete it. I know some engineers, I completed mine 24 months and 1 week also, complete with signatures and so on. I know someone who has just completed her 24 months and she is ready with her report. Okay. So we advise our trainee engineers to work in this perspective. So if you're not able to complete 24 months, it's going to be 25, 26, 30 months. Okay, because at the CV, we have a formal structure, okay, that they have the different competencies. They are able to move around different departments to be able to gather, to have these different competencies. But in different, maybe organizations may not be different. Maybe you miss maybe part of project management, you need to extend here and there. So this is okay, but you need, you will know yourself, okay, you are grown up now, and you need to be able to put some deadline on when I want to submit my report to make it ready at least. Okay, so minimum is 24 months of training. Not only 24 months, it's 24 months of supervised training on full-time basis. OK, supervised training. So we have just moniteur d'auto-école, quand je fais causer avant. So we need to have someone who is going to look look upon our training, guide us in our training. So this person, this supervisor, we have some specific criteria for them as well. Okay, let's have a look at who he must be. He must be himself a registered professional engineer. Okay, you can't have someone else supervising you. He must be a professional engineer, at least 4 years post-registration experience. He's not someone who has just got his registration last year and he's starting to supervise you. It's good that you give advice. Okay, you can, I expect this from you as well. As soon as you complete, you can guide the youngsters. Okay, you need to do this one. You need to start writing your report, giving general advice, but you can't supervise as such. Okay, he needs to be someone who has at least 4 years after he has registered for the first time. Then it should be in the field of engineering. You can't be undergoing a training in electrical engineer, but you are being supervised by a civil engineer. So he needs to be someone in your exact field. Now, when I say exact field, we have some commonalities, some discussion which can be which can start in terms of mechanical, mechatronics, manufacturing, and so on. I think if you are having such issues, maybe Mr. Dalia can share his point of view later on. But here we're speaking about the generalities about all these. Okay, and your supervisor need to be duly registered during the said period. Let's say you have not only the said period, but he has to pay to be like he has to be paying his dues, yearly dues, with the council after you register. Okay, there are yearly fees that you need to pay to the council to remain on the roll. Okay, we are going to see the fees later on, but then he needs to be paying his fees. Okay, so then he's fully registered, he's fully fledged to supervise you in your training. Okay, just checking the chat. Okay. Okay, now advice for you as young engineers, young trainee engineers. Okay, important is to keep a very good log. Okay, your recording. Okay, it's not about we have a logbook which is provided for us by the council, but you need to have your hardbound copybook. Pas un petit cahier, un petit cornet qui vous pouvez mettre dans poste, etc. You can have it, but then you need to translate everything into a proper recording. So I recommend a hard hardcover copybook, okay, so that you can write all what's happening on a daily basis, okay. Even though, okay, the Jamang nous rappelle, nous connecter ça, but then our mind has been wired in such a way that it's going to stay for a few hours, 1 day or 2 days, even a few weeks, then afterwards going to go away. Just like I'm going to ask you, what did you eat last Thursday? Not yesterday, but last Thursday. Most of you have forgotten, and that it was your birthday. So we have spent like 30 minutes eating dinner. Okay, we had enjoyed it, but then after 1 week, we have already forgotten what we have eaten. Similarly, when we are going on a site, record everything, maximum amount of information, have hand sketches, drawing, connection diagram. I'm speaking from electrical perspective, but for civil, mechanical, and so on, you will be able to understand what I mean by taking proper reading and recording. Important because you're going to lose it. Nowadays, we have what we call phones, mobile phones, and so on. They try to click pictures. That's good, but then you need to transfer it as telephone, PRG, memory card. I don't know what happened, and so on. You lose all information. So you need to have like a proper recording. Let's say you have been on site, you have taken pictures, and then you keep it. Okay, I have it on my mobile. After 1.5 years, I'm going to start doing my report. But then things may have happened. Your phone may have dropped into water, and so on. It may be damaged. You are losing all your files. And I've seen it practically all. Anyway, anytime I say that, I see something new. So I've seen people losing, my trainees losing their mobile phone, thief coming into their home to steal their laptop. Okay, so that's why you need to back up maybe on cloud. I don't know where you're going to back up. So have different backups of your report, of your data, okay? And your data being erased, maybe crashing of your Windows or things like that. So you need to have a proper way of recording at different maybe milestone in your maybe every month you make a backup on where you are, you record it properly, you take different pictures, you put it in different folders that you know where you are going. And important as well is nowadays what I am advising my trainee is that, okay, when you go on site, don't only take pictures of the equipment. Okay, you can bring more value to your report if you are working on the equipment and someone is taking your picture working on the equipment, or if you're doing a measurement, someone taking your, so you are you're the subject of the picture itself. Okay, so when you're going to put that in your report, it's going to bring much more value to your report. Okay, else we have a training record book which is given, which you need to fill in and submit for your registration. So this is a look of it. You have it, it is downloadable from the CRP website. Okay, so the engineer under training must submit to the supervising engineer a quarterly report. Okay, I think it was disconnected. We just got like a disconnected. Let's get back on track. So where were we? Oops, let me check. We have not read there yet. Yes, we were at the training book. Okay, hope we are all here. Let me just check. Yeah. Okay, let's continue. So every 3 months, okay, you need to submit this form to your supervisor and make him agree, not making agree, but checking his understanding about, okay, these are the activities that you have been supervising me in, you have been appointing me to do, and he's going to sign, he's going to give you his remarks and so on. Important now, you may be having different supervisors, okay? It may happen that you have one supervisor, one engineer, he's going to monitor you from day one up to you complete your report, your training program. But it may happen that you are changing maybe departments, you are changing companies, you are changing even, you're moving companies. So then it's a bit difficult to go back to your previous maybe department or looking for this engineer who was supervising you at that point in time. Okay, it's going to be difficult. Maybe he has gone to Canada. Okay, maybe he has disappeared. So the best approach is every 3 months, go and make him sign your training record book. This is a training record book. What I advise as well is that the part where he has been, if you're writing your report, okay, you have completed maybe an assignment, you can even make him check it and maybe countersign or things like that. You are on track, okay? This training record book is very important, okay? So this signature every 3 months, look for your supervisor and track him so that you are able to complete your, because I've seen so many things happening that, okay, maybe the engineer has moved, he was here, he wanted to sign everything at that point in time, but then he has moved company, he don't want to hear about what happened in the last company and so on, and you need to track him, you need to know where he's working, so it's going to be complicated for you. Okay, so based on experience, I'm telling you that, okay, go every 3 months to make your record book, to sign your record book properly. Either the engineer responsible for training or the supervisor should sign and signify that he approved, okay? He just need to, there's a space at the bottom of the form for the signature. Okay, now the big chunk of the presentation, okay, is about the technical report writing. Let's see. Question now. Okay, when should we start? What is the best time to start writing the report? Anyone? So we have 24 months. Okay, so maybe after 1.5 years, avec on arrive 20 mois pour là, 20 mois pour là, but it's okay, you have got enough material and you know where you are going now, okay? And yeah, I think it's the best, maybe after 20 months to start writing the report. Good or wrong? Okay, so you should start on day one itself. Okay, but then you will tell me, okay, but I don't have anything to do on day one. I don't know, I don't even understand what the company is doing. But then you can open a file. This is what I usually say: open a Word document and rename it my registration report. So you have started. This is a starting point. You have created a document, and at least you can use a cover page. Okay, your name would be changing unless you are married and so on, but your name is going to remain the same. Okay, so you can start with maybe at least formatting the document, having a look at what types of formatting I will need to do. Okay, reading through the document. So this process has started. Okay, that's good. So most of the time, this is what we advise. Okay, then most of the time, what happens is that when deadline comes too close, n'arrive 24 mois, 23e mois, okay, I think we need to start writing most of the time. What do we see? Oh, you have started to write, and during maybe first year, you have written 1 or 2 pages or things like that. This is what's going to happen. When you read reports, you will see that, okay, it's the way they have the student, the participant, the candidate has started to write the report was very good. First chapter, top. Second chapter, very good. Then when it comes to chapter 3, chapter 4, you can see the momentum has gone down, okay? And the quality of the report has gone down. The amount of punctuation errors, the language that is being used is going down. So you can, this is what we shall picture this, a report. Like when the deadline is too close, you're trying to submit a report. I need to submit it in, I said previously, 24 months, put your deadline, yes, but then you need to work to your deadline. You can't say, okay, I need to take 3 meals a day, breakfast, lunch, and dinner. Then you say, okay, I have not been able to have breakfast and lunch. I'm going to eat everything at dinner. So at dinner time, you eat breakfast, you eat lunch, you eat dinner. You won't be able to do that. So you have specific times you need to spread this work over the amount of time which is given to you. Okay, so this was, okay, Mr. Dalia is saying to you, download the registration pack from CRP website on day one. Yeah, okay, good starting point from there. So how many chapters now do we need in the book? So it's just like, okay, I want to write 10 chapters. Why can't I? Okay, because we have a protocol, we have a guideline which is given to you about how to write these chapters. It's not like you're writing a novel. Okay, so we have an approach that everyone is able to submit as per specific guideline, and then it is a homogeneous approach to engineering report writing. So chapter number 1 is about background. So what is background? An introduction about yourself. Who are you? where have you been doing your studies, and what have you done after graduating. Okay, at times you work in different companies. This is to give you an introduction about yourself, your professional employment history, maybe from when you graduated in 2005, 2007. I was working in this manufacturing company, and then I moved to this company. Maybe I could not do registration there because there was no registration. So you can just give the audience, so the one who's going to read your report, a brief introduction about you and what you have been doing. Then important is to demonstrate your time utilization. Engineering design, so it is grouped in different quadrants. Engineering design, including project management. So the design part, we mentioned about the importance of design as an engineer, your own field of engineering. Okay, then allied engineering. So what is allied engineering? Let's say I'm working as an electrical engineer at the CB. Okay, I'm doing designs, electrical cable sizing, and location and so on. But I need to work with civil, and if I'm building a substation, I will need to liaise with the civil engineer over there. Okay, I need to have some sleeve being laid underneath here in such a way. So I'm collaborating with civil engineers or mechanical engineers if I'm working in a power plant as well. Okay, so you are going, it's not going to be like wearing blinkers or I'm done engineering. He said that we need to focus only on our field of competence. I'm going to focus only on electrical. It doesn't work that way. So it's a broader, you need to have a broader perspective. You won't be giving advice on these different engineering approaches, fields, but you need to have a holistic understanding about what's happening all around you. Okay, and then you need to have some part of administrative as well. Okay, but administrative should not become 45-50% of your time utilization. Okay, I think we are going to discuss on that later because it's going to be, there's one part of assessment which is on your time utilization. Next chapter is chapter number 2, the training environment. Okay, so what is it all about? The nature of the engineering environment exposed by the trainee. Okay, so first chapter was about yourself, what you have been doing, how you have been using your time, and so on. Next is about where are you working. So if you are working in a specific company, give a brief description about this company. What is the mission and vision? What is the output? Is it like a manufacturing company? What is the company all about? So this is the first part of chapter 2. Then you go into the details as well. Okay, it is maybe a manufacturing company, manufacturing shirts, that's good. But then what is the engineering now? Okay, you have been exposed to these different parts, maybe maintenance and so on. So you start to expose the engineering part of this company. Okay, complexity of the activities or operations as a training organization. So you may be working, you say, okay, I've done 24 months in a manufacturing company. Okay, or even let's say, I take the example of the CB. I have 24 months of training at the Central Electricity Board, but then for 24 months, I have been posted in the, let's say, the procurement department only. Okay, so I'm going to be like a master in procurement, but the importance of me being posted as Central Electricity Board was to get training in engineering. So you may have been working in an engineering company, but then you have not been posted in the right section or department. So you need to explain where you have been undergoing your training, whether it is like an environment conducive for you to have been doing your training environment. It's going to come later on, definitely, but this is like an introductory part to this training, to your report. Okay, then you will need to put an organigram. So where were you? How many people are there in this company? How is it organized? Do you have a senior engineer? Where's management? How many departments, depending on the size of the organization? And then you should show where you were positioned there. And if there were teams working under you as well. Maybe at times you have maybe technical officers or technicians working under you. You need to show that because it's going to give an idea about whether you have been able to lead people working under you, because you need to demonstrate leadership as well. Remember, we talk about competencies, which we're going to discuss later on. But if your people are working under you, how have you been maybe organizing, managing these people? Okay, this is a part of leadership. So organigram is important to show. Who are your supervising engineers? Remember, we have criteria for that, which we have discussed. So you have to write their names, the RPM number, okay? And this will give you an idea, an opportunity as well to check whether they're registered, and not only registered, but they're paying, they're on the roll, they are appearing on the yearly roll of the CRPE as well. Now, there's one issue that, okay, you may be working in an environment, an engineering environment, which is good for you to do a registration. You have engineering design and so on happening over there. But unfortunately, you don't have a registered engineer who meets the criteria, as we have mentioned before, for being a supervisor. So this has been there's an approach for that. There's a method which can be used. So you need to have an approval. You need to look for an engineer from an outside organization, or maybe from another maybe company and so on, who has the qualification, who meets the criteria to be a supervisor for you. Then this person needs to be agreeable that he's going to supervise you. So company where he's working needs to be agreeable, because at times, if let's say you're working at MTEL and someone at Mauritius Telecom. So it may not be that, okay, someone from MTEL is supervising someone from Mauritius Telecom. So it may not look good. Okay, there may be a conflict of interest and so on. And it's not like a good approach. So the company where the supervisor is going to be, and your company, they need to be agreeable and so on. So both parties, your supervisor, the company where your supervisor is, and your company needs to be agreeable, and letters needs to be sent in this way so that you can have like an external supervision. Okay, so chapter number 3 now. Let's recap. Chapter number 1, introduction about you. In chapter number 2, a brief idea about where you're working, who was your supervisors, and so on. This is chapter number 2. Chapter number 3, now we are getting into real business, the nature of training received. Here, let's see, report on engineering activities of the organization. This is chapter number 3, basically is when the first 6 months of you're joining an organization, so you're learning, because we have learned a lot of mathematical formula, a lot of practical things as well, okay, at university level. But here you are seeing it in real life. You are implementing it, or you are visualizing what you learn. Okay, most of the time, new things as well, because what you have learned is a bit it's too simplistic. But then you will need to use these fundamentals that you have learned and apply it in real life engineering world. So you will need to understand, okay, oh, this is a cable. Okay, we are going to build a system in this way. So you are getting involved in design, you are maybe maintenance and so on. So you are getting used, you're getting the terms, you're getting, you're visualizing, you're attending site visits and so on. So your grooming is starting. So report on engineering activities of the organization. What is the organization doing? Demonstrate initiation into activities. So it's not about, okay, Kasenpo, Nugete, okay, Zoji Banline, I'll faire maintenance. You know it, okay, today they have gone to do a repair or a maintenance of a transformer. Okay, that's good. You have reported on an activity, engineering activity, which has been done by the team, but have you accompanied the team? Have you maybe participated in the activities? Maybe doing some tests, you're learning, maybe first time you're going to see they're going to use a megas, they're going to use a tester, a voltage meter. What is the safety precautions that are being taken? Okay, just do you go directly and start testing the transformer? No, you need to switch off, isolate, test the system, earth it, and so on. This is the process you're noting. So you're getting used to the methodologies, to the approaches. It's about demonstration, initiation. And then maybe after 6 months, they may give you, depending on your supervisor, so someone who's going to accompany you, they're going to give you, okay, now you carry on this test. Okay, tell me what will be the exact procedure before intervening on this switch gear. Now you're getting used to the environment. Okay, projects you have worked on. Okay, so things that you're doing, maybe you have been accompanying your supervising engineers to this project. What have you learned? It's not only about technical here. Okay, maybe during a site meeting, there was some conflict on the site. How did they manage this conflict? Maybe your supervisor or yourself, if you are empowered to do so. How have you managed a conflict? between two subcontractors or between two contractors. Okay, these are things that you can report on. Okay, so you are, okay, you are learning about the tips and tricks of the trade. Awareness, familiarity, and appreciation of engineering activities. So you are aware, okay, I have different types of cables: copper cables, aluminum cables, you have overhead cables, underground cables, insulated cables, different voltage level, high voltage, medium voltage, low voltage. So it's an awareness. Maybe you were not aware when you know, okay, we have cables, but then you have different size of cable, different construction of cables. So you are being aware. Same for reinforcement. If you are in civil engineering, you will start to to learn about these different activities. So you need to be aware, to show familiarity, okay, and appreciation of these engineering activities. I can understand from here that, okay, you should be trying to picture where you are correct in your organization. I'm speaking mostly from a heavily bias of electrical engineering, okay, but if you are in civil engineering, mechanical engineering, I hope you're able to picture what I'm meaning by these different topics here. Let's move forward. Okay, the nature of the training received. Okay, it's still chapter number 3. Understand and apply the basic law of physics. That's important, because what we have learned, what we use most likely is what we have learned at physics, the physics at HSC level, and the first year or second year of engineering. These where we apply, we learn the basic law of physics and engineering. Okay, and most of the time, whatever you see in the application that you are seeing in your companies and so on, we are going to use these different laws. So everything boils down to these different principles. Example, again, I'm heavy bias for electrical engineering, but try to see it from your perspective as well. If you're from a different field, doing earth measurement, earth resistance measurement. Okay, now there's different method, 3 piqué, 4 piqué, and so on. So you have the equipment, you will understand why we are doing this earth resistance measurement for lightning protection, for improving the earthing system. So to be able to have an earthing which is going to be less than 5 ohm as per IEEE recommendation. So this is a new thing that you are getting from the environment, the company. But then the principle of using this equipment, okay, you have different spikes that you're going to put in the earth, and then you are going to inject current, measure voltage, and so on. So basically, you're using Ohm's law to calculate the resistivity of the resistance and then resistivity of the earth. Okay, the underlying principle is still the basic law of Ohm's law. Okay, but the application is different, and the method is going to be different, and the importance, because now you are applying this law not only to find value of R as we have been doing in exam, but to be able to know whether this R, the value that you are having, is it okay? Is it going to be enough for me to manage my my earthing system, my protection system? Okay, so you are linking your basic understanding of engineering or the law of the first principle and applying it to the real world to see whether you are able to do a proper protection study and so on. This is one. I understand that for civil engineering as well, you have Archimedes principle. So everything is going to boil down to these Ohm's law, Kirchhoff current law, Kirchhoff voltage law, and so on. Basically, all of these boils down to this simple law. We had one question there was someone from networking company, okay, and they were explaining to us about during an interview, okay, and the cabling, the optical cabling that they have been installing here and there, big project. But then we asked, what is the basic principle in optical fiber communication? Okay, he was explaining so many different terms, equation, given equation, but the question was quite simple. What is the principle that is used in optical communication? So what you have learned in physics, I think it's at HSC, it's total internal reflection. Okay, this is the You are using that. So you need to go back to the basics, to the root, and then from there you can work on, you can say, okay, there are different cladding now. How well you can improve this cladding to be able to have proper transmission over long distances. Now we can't go beyond that. We need to put a repeater and so on. So basically you need to go to the basics. Basically you need to go to the basics as the fundamentals, and then you can work from there. Okay, always. Why is it so important? Because at times we try to move towards the software. Nowadays, we just input parameters in the software, it's going to work it out for you. But then understanding software is going to be important as well. Okay, let me just check the chat. I think it's flashing. Okay, hopefully I'm just checking. I think you have lost me. Okay, I think it's still around. Let's give it some time to just go back. Okay, so maybe too many people on Netflix and so on. Okay, so we're discussing about the importance of applying these basic principles. You will need to learn about the software because you can't. Okay, so here we go again. I'm going to share, go back to where we were. Okay. Yeah, so we need, because most people are on Netflix and everything. So we just need to, let's see if I can admit a few more people. Okay. So let's continue to where we were. And so let's put that on, here we were. So understand and apply the engineering principles. So I was telling you that we need to be able to know the basic principle. Then ultimately, next chapter, I think chapter number 5, we need to show that we understand software as well, which for every calculation that we are going to do, we should know what's happening behind the software. What is the principle the software is going to use? We can do that manually as well, most of the time. But then when it gets complicated, we can't do it manually if you have lots of simulation and permutation to do. But then we should understand what's happening first. Okay, so these work hand in hand. Understand it from first principle and then using the software as well. Understand and apply basic engineering principles. Okay, report through drawing, schematic, and block diagram. Here I will stop again. And engineers, we communicate. Yes, we said that engineers, we need to communicate very well. And then we communicate, we know how to write good English and so on, but we also need to, anyway, we communicate much better through drawing, schematic, and block diagrams. Okay, this can be flowchart and so on. So it's a way by which we engineer, we communicate better. So no need for you to write a lot of the literature to describe if a drawing can bring you much, can transmit, can provide much more information to the audience. Okay, now, so this was about chapter 3, where you are learning what's happening, the engineering happening in your training environment. You are maybe doing some tests and so on. Okay, that's okay. But you know now what's happening in your environment. Next chapter, maybe most important one, is about your personal contribution. Okay, it's good to go to the gym every day, but if you go to the gym and you don't sit down, okay, this is chapter 3. Okay, I know to train legs, I need to do this exercise. To train my biceps, I need to use this equipment. I need to use this dumbbell and so on. To be able to lose fat, I need to jog on this equipment and so on. This is chapter 3, you know. But now, if you just sit in the gym and you don't do anything, you won't be fit. Okay, you won't get muscles, won't grow and so on, won't develop. Now you need to sorry for that. Let's see, we get back to where we were. Okay, I'm just going to repeat this slide. So I was telling you, let's compare that to where let's say you go to the gym. Chapter 3 is going to the gym. Okay, You see there's one equipment which you can use to grow your biceps. I think we are having a very bad connection right now. Let's try again and see. Okay, I think this is a peak time. Okay. Sorry for that again. So let me just check the audio is okay. So I was telling you, I think the example of going to the gym is not good because every time I'm taking this example, it is like disconnecting us. So I was saying, but I think it's a very good example. If you go to the gym, you sit and say, okay, this equipment I'm going to do, I can use this equipment, this set of dumbbell to grow my biceps. I can use this equipment to train my legs. I can, if I need to lose fat, I'm going to use this equipment. So you are sitting around and you know what needs to be done to grow yourself into a bodybuilder, things like that. But now chapter 4 is you go to the gym, but then you need to train. If you just only go to the gym and sit around, okay, I know how to do that, I know this and this, you won't be able to grow. You are still going to be the same. Okay, but if you want to develop your muscles, you need to start grabbing the dumbbell. This is a personal contribution. You need to start running on this treadmill. You need to start going into and doing some squat. This is personal contribution. Now you are going to show, you're going to demonstrate that you are able to do some projects as well. Personal contribution. Let's see. So you need to show active involvement in design activities. Okay, so what is design activities? I think we can discuss much more about that. Let's see what we have more. Okay, monitoring engineering metrics at different level. Okay, maybe measuring what's maybe happening before an improvement, maybe just making a measurement, and then things are not within the acceptable range, you can improve. Let's say let's go back to Irving. You